Hello everyone, today we are going to analyze this overhanging beam. In this beam, the portion AB overhangs by 2 meter. The portion BC is 6 meter and it is simply supported. In the overhanging part, there is uniformly distributed load 3 kN per meter, and in the simply supported part, there is a uniformly distributed load 9 kN per meter. To find RB, let us take a moment about C. In this case, we have to follow right hand side rule. This UDL is acting in the anti-clockwise direction, so it will be negative. For the UDL, we have to multiply the area with the centroid distance. For this rectangle, the area is 3 into 2. We know that the centroid of a rectangle lies in the center. From the center, the distance to the point B will be 2 upon 2. But we are taking moment about C, so we have to add the remaining distance as well, which is 6. RB is acting in the clockwise direction, so it will be positive, and the distance is 6, so it will be 6 RB. This UDL is acting in the anti-clockwise direction, so it will be negative. The area is 9 into 6, and from the center of the rectangle to the point C, the distance will be 6 upon 2. For RB, we will get 34 kN. To find RC, let us take moment about B. In this case, we have to follow left hand side rule. RC is acting in the anti-clockwise direction, so it will be positive, and the distance is 6, so it will be 6 RC. This UDL is acting in the clockwise direction, so it will be negative. The area is 9 into 6. And the centroid distance about B is 6 upon 2. This UDL about B is acting in the anti-clockwise direction, so it will be positive. The area is 3 into 2, and the centroid distance about B is 2 upon 2. For RC, we will get 26 kN. Alternatively, using this rule, we can find RC very easily. RB and RC are acting upwards, so both of them are positive. These two UDL are acting downwards, so both of them will be negative. For the UDL, we have to take the area, which are 3 into 2 and 9 into 6. For RC, we will get 26 kN. Using the right hand side rule, let us find the shear force values at A and at B. In the overhanging end, the shear force A will be 0. Let us find the shear force at just left of B. This UDL is acting downwards, so it will be negative. For the UDL, we have to take the area, which is 3 into 2. In this way, we will get minus 6. Let us find the shear force at just right of B. With this, we have to add this. This reaction is acting upwards, so it will be positive. In this way, we will get 28 kN. To find the shear force values at C, let us use the left hand side rule. Shear force at just to right of C will be 0, and at just to left of C will be RC, which is acting upwards, so it will be negative. Here you can see the shear force diagram. In this point, the shear force becomes 0. In this point, we have to make a section and find the distance, because in this point there will be maximum positive bending moment. You can see that I have made a section XX at a distance of X from C. If we make the section from A, it will be little difficult. That is why I have made the section from C. Using the left hand side rule, let us find the shear force about the section. RC is acting upwards, so it will be negative. This UDL is acting downwards, so it will be positive. The area of the rectangle is 9 into X. We know that in this section the shear force is 0, so we can equate this to 0, thereby getting X as 2.89 meter. Using the right hand side rule, let us find the moment at B. This UDL is acting in the anti-clockwise direction, so it will be negative. The area is 3 into 2, and the centroid distance about B is 2 upon 2. For the moment at B, we will get minus 6. Using the left hand side rule, let us find the maximum bending moment. RC is acting in the anti-clockwise direction, so it will be positive, and the distance is 2.89. The UDL is acting in the clockwise direction, so it will be negative. The area of the rectangle is 9 into 2.89, and from the center of the rectangle the distance to the section is 2.89 upon 2. In this way, for the maximum bending moment we will get 37.55. In the overhanging end A and in the simply supported end C, the moment will be 0. Here you can see the bending moment diagram. In this point the moment changes its sign from negative to positive. This point is called the point of contra-flexure. We need to make a section in this point and to find the distance. You can see that I have made a section XX at a distance of x from C. Using the left hand side rule, let us find the moment about the section. RC is acting in the anti-clockwise direction, so it will be positive, and the distance is x. This UDL is acting in the clockwise direction, so it will be negative. The area of the rectangle is 9 into x, and the centroid distance about the section is x upon 2. We know that about this section the moment is 0, so we can equate this equation to 0. From these two we can take one x outside. 0 upon x, it will be 0. For x we will get 5.78 meter. If you wanted to find the distance from A, we know that the total distance is 6 plus 2, so it will be 8. 8 minus 5.78, we will get 2.22 meter. Now we are going to end this session. Thank you for watching this video.